Okay, so we're going to look at example 2 now. Sorry I ran out of time for the last video, so we're going to pick up where we left off. So we're going to use those same strategies to sketch this graph here. So first of all, what do we know? We know that a polynomial is a smooth, continuous curve with no sharp turns. The mathy way to say that is that the graph is continuous and differentiable. Okay, number 2, we know our x-intercepts. Our x-intercepts on this one will be 2, 0, because the x-coordinate that makes this 0 is 2. The x-coordinate that makes this factor 0 is -3. And then the x-coordinate that makes this factor 0 is -1. So we've got -3 and -1, 0. So we know those. So we're going to go, let's start scaling off our axes here so that we can plot our x-intercepts. So we're going to go, we'll do this again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. iPad is freaking out. Let's try that part again. Okay. All right, so we plot these. I'll do them in red. We've got 2, 0. We've got -3, 0, and we've got -1, 0. So right now it's kind of like the last graph we did. Right, same zeros, but let's look at how the graph is different. So if we do our sign testing, so up here we tested our axes and that we made our axes. So we're going to test for positive or negative y values. All right. So I make a big test interval. That's like our x-axis, starting at -infinity, ending at infinity. We have a 0 at -3. The y value is 0. At -1, the y value is 0. And again at 2, the y value is 0. So now we're going to test for positive or negative. So we're going to pull a value off of here, an x-coordinate off this interval, like -4, and we're going to plug it in. F of -4. This graph here is g, actually. G of -4. And I'm going to write the equation down here again. So g of x equals 1/4 x minus 2 squared times x plus 3 to the third times x plus 1. So I don't have to keep scrolling up. All right, so g of -4. I had 4 there, but it's -4 because we're pulling an x value off of this interval, -4. They're all going to be the same as -4. If -4 has a positive y, these are all going to have positive y's. All right, so we just want the sign. So 1/4 is positive. If I plug in -4 here, it doesn't matter what I get because when I square it, I get a positive value. When I plug in -4 here, it will matter because when you cube it, you could get positive or negative. So if I put in a -4, -4 plus 3 is -1. -1 to the third power is a negative because a negative times a negative times a negative, that's a big negative sign. Sorry, the iPad is freaking out. That's a negative. And then this last bit here, if we plug in a -4, -4 plus 1 is negative. So a negative times 2 positives, that all works out to be a positive. So G of negative 4 is positive, and we know the graph is above the x-axis. Now on this interval, we're going to choose a number between negative 3 and negative 1. So that number is going to be negative 2. So if I plug in g of negative 2, I know I get a positive, and then when I square, I get a positive. So I know it starts off positive, positive, no matter what. And then when I plug in negative 2 here, I get a positive, because negative 2 plus 3 is positive 1. And a positive times itself 3 times is still a positive. And then when I plug in negative 2 here, I get a negative. Negative 2 plus 1 is negative 1. So that's going to be a negative. So g of negative 2 will be negative. So there is a sign change and will be below the x-axis. There is a sign change at this 0, at negative 3. We go from above the graph and we're going to cross to below. Now we're going to see what happens here at this one. I'm going to pick a value between negative 1 and 2. So I'm going to do like g of 0. I know it's going to start off positive times positive, because once again, 1/4 is positive, and then anything that I plug in here doesn't matter. Squared is positive. Now when I plug in 0, 0 plus 3 is positive, and a positive to the third is positive. And then when I plug my 0 in here, 0 plus 1 is a positive. So everything's positive, so we get a positive. So g of 0 is positive, which means we'll be above the x-axis. So we have a change of sign here. When we come up to this 0 from the bottom, it's going to switch over and go above, because we have a change of sign from negative-wise to positive-wise. Now at 2, I'm going to find g of 2. I know it's going to start out positive, positive, because there's no other start that it can be, because 1/4 is always positive, squared is always positive, and now we're plugging in 2. So 2 plus 3 is positive, 2 plus 1 is positive, all this stuff's positive, everything's positive. So then g of 2 is positive, so we're above. So at this one, the graph, the y values are positive. We come down and we hit 0 at the x-axis, but then we're going to bounce off and stay above. There is no sign change at this 0. We go down, we touch it, turn around, and go the other way and stay above. We call that bouncing. If you could kind of visualize, it comes down and bounces off the x-axis, right? So let's get this thing graphed. So we know it starts off above, and at the 0, negative 3, starts up above, and we cross down below. Now, I don't know how far down it goes, but I know that it goes below, and at some point it has to turn around and come back up to this 0, and that's at the 0, negative 1, where we were below, and now it crosses, and there is a sign change, and we go from negative-wise to positive-wise. So now we do a sign change from negative up to positive. And then we're going to come back down towards here. And again, I should probably check. I think it's going to bounce here, right? Because now we are above. We hit 0 and stay above, so it's going to bounce. So I'm going to make like a little mini parabola here. It's going to bounce. So what I'm going to do is, before I come down with the other part, I'll make a nice smooth, so it's not that sharp turn, because we can't have sharp turns. I'll make a nice smooth curve there, and I'll come down and connect it. It bounces and comes up and goes that way. And that's how we would graph that. Look at the difference. Oh, these are the same. So let's look at the difference. So at this, I wanted to mention, what happens here at this 0? At negative 3, we said it crosses. There's a sign change right here. But it's a little different because of this third, this power of 3. It's going to cross. But let me show you what's going to happen there. At that 0, it's going to be like a little cubic. You know how x to the third looks like this? It's going to cross, but it's going to make a little shift like that, just like a cubic. Do that again. Right? It's going to do that. And then we go down and we come back up. So it crosses, but it does like a weird, different kind of a cross here. So here's what I'm going to say that we're going to learn. This is going to be the summary. When you're at a 0, sometimes it looks like a little mini cubic where it crosses. Sometimes it just looks like a line where it goes straight through. I'm just focusing on, I'll highlight like what we're talking about here. We're talking about right just at this part right here, really close to each 0, we see we have, this one's like a cubic, a little mini cubic, or an x to the third. If we know our parent functions, it's kind of hard to see my writing there. Over here, we have a linear, or like an x to the first. It's like a line, it just goes straight through. So even though they both cross, they do like a little cubic as it crosses. Over here, when it bounces, it's like a little parabola. It's like a little mini x squared. So how do we know which one it's going to do? Well, at each 0, it goes by the power. So since this is a squared, that's where we're going to do like our little mini parabola. Think of your parent function. At that 0, it's going to just do like a little parabola. Maybe it bounces that way, maybe that way, but it's a little mini parabola. At this one, at this 0, because it's a 3, it's going to do like a little mini cubic. And at this 0, since the power is 1, it's just going to go straight through. I think it's like a mini linear. So I'm just talking about in its area. If you zoom way in and just look, if you just look in its area, you have a little cubic, you have a little line, and you have a little parabola. And that's how you'll know what it does based on the power of the exponent. Now, when you have an exponent, that's called a repeated root. So the number of times it repeats tells you if it bounces or not. Okay, so let's generalize what we have discovered here. We have discovered that if, oh my God, this is so bad, I'm sorry. See if I can get this together here so it's not, if I write slower. So we're going to say that if our root, or remember that means the same thing as 0, repeats, these are called repeated roots. If it repeats an even number of times, that means it has an even power or an even exponent. Either one of those words works. There is no sign change. That means it bounces off the x-axis. I'll say that, it bounces off the x-axis at that 0. That's the first thing we know. Then kind of the second scenario is if our root or 0 or x-intercept, whatever you want to call it, repeats an odd number of times, that means it would be an odd power. Right? Then there is a sign change. That means it crosses the x-axis at that 0. Okay, so we're going to use this information to try to shortcut graphing so we don't have to do that test interval thing. All right, so first we can figure out end behavior. So the sign of the leading coefficient. Well, if I multiplied these out, the first term would come from all of these guys. And that would be 1/4 times x. So our first term would be 1/4 times x squared times x squared. So then that would turn out to be 1/4 x to the 5th. So that means our leading coefficient would be positive, and our degree would be 5, which makes it odd. So that means our end behavior, well, if the leading coefficient is positive, that means it will finish going up to positive infinity. And since the degree is odd, that means they would be opposites. So on the left side, we would have the opposite of going up, we'd be going down. So on the left, just to use not math expressions, on the left, we know that we're going down. And on the right, we know that it's pointing up. That'll help us with our graph. Zeros and their multiplicity. Zeros are the x's that make this 0. So 4, 0 is an x-intercept. I like to write them as points. You could just write 4. You don't have to write 4, 0, but you got to understand that's the point on the graph. And then its multiplicity would be how many times is it repeated? It's only once. The power is 1. You only see it once, so its multiplicity is 1. And we just generalized and said, if the 0 repeats an odd number of times, which it does, its multiplicity is 1, there is going to be a sign change in our y's. If there's a sign change, that means we are crossing the x-axis. The next 0 is whatever x makes this next factor 0, which is -3. So then we have the x-intercept -3, 0. And that has a multiplicity. This guy, it's repeated how many times? Well, because it's squared, technically I could write this thing like this. X plus 3 times x plus 3. That's what squared means. So its multiplicity is 2. You don't have to write it that way. You can just look at the exponent. And we said if our multiplicity is even, there is no sign change. So the y's, if they were positive, they touch that 0 and stay positive. If they were negative, they touch that 0 and stay positive. So we call that bouncing or touching the x-axis and goes back in the direction that it came from. And the last 0 is -1. So it's repeated. How many times is that multiplicity? This root is repeated twice because of the 2 right here. So it has a multiplicity of 2, and therefore there would be no sign change, so it will bounce. All right, y-intercept we could do just because it's kind of easy. You just plug in 0 for x and solve for y. So if I plug in 0 for x, I got f of 0 equals 1/4 times 0 minus 4 times 0 plus 3 squared times 0 plus 1 squared. Oh, my garage door was opened. So then I got 1/4 times -4 times 3 squared times 1 squared. F of 0 equals 1/4 times -4 times 9 times 1. Now I multiply these together, I get -1. I multiply these together, I get 9. I multiply these together, I get -9. So that's my y-intercept. So now we can sketch a graph. Y-intercept is just also nice to have. 1, 2, 3, 4, 5, -5, 6, 7, 8, 9, 10. I don't like to label every one. And then we'll go 1. These x's only need to go up to like 5 or 4. So I'll go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 5, 6, 7, 8, 9, 10, 10. All right, so let's start graphing what we have in red. We have a y-intercept of 0, -9. That's just nice to have. It's kind of like an extra point to hit when you sketch your curve. So since it's easy to do, we just go ahead and figure it out. Then we have the zeros 4, 0, -3, 0, and -1, 0. So that's where it's going to touch or cross. Those are the zeros. Now we're going to use our sign changing in our end behavior. So on the left side, it's pointed down. That was supposed to be a highlighter, or the pointer. On the left side, it's pointing down. So coming out of this 0, it's down like right here. right? It's going to, I don't know if it's crossing or touching. I'll figure that out later, but it's going to become pointing down, and then we're going to come up here and draw this, okay? Then over here on the right side, it says our end behavior is up. So after I leave this 0, I don't know if I'm bouncing or if I'm down here and I'm crossing, but after I leave this 0, I'm going to go up. So I know the end behavior finishes up. So we start by filling that in. Now we're going to fill in all the middle stuff. So I'm going to come up and go to this 0. And at the 0, -3, we have to see if it bounces or crosses. No sign change, it bounces. Its multiplicity is 2, so it's like a little mini parabola. So sometimes I like to just draw that in first. All right, so we started down here. We're going to bounce, come down. Then we're going to come back up at this 0. At the 0, -1, our multiplicity is also 2. It's going to bounce again. Since it's multiplicity 2, it's like a little mini parabola. So we're going to go down, we're going to come back up, and it's going to bounce again like a little parabola. So I'm going to bounce it. It's going to go back down. It's going to hit this y-intercept, and then it can turn around and come back up here. And when we get to this 0 of 4, it looks like it's going to bounce. I'm sorry, it's going to cross because it's an odd multiplicity, so it's going to cross. And it's a multiplicity of 1, so it's just like a little line. It's going to do like a little mini line, not a cubic or anything. It's going to be straight as it comes through there. So now I can connect. We're going to come up here. We're going to bounce. We're going to come down, turn around at some point. I don't know how far down I go. Maybe I go this far. Maybe I only go this far. It doesn't matter. You can't figure that out. That's why it's a sketch. This is not an exact graph. We're going to come down, turn around, and come back up. We're going to try that again because that was wild. We're going to go down, turn around, come back up. Bounce, come down. We got to hit this guy and then turn back around, come up, cross straight through, and go up forever. And that's how we sketch that graph. So now you can sketch polynomials. It's a lot of information. We're going to practice, okay? Now let's try this guy. This is our last example. This one's the same stuff, but we might have to factor at some point to find our zeros. But let's start with the leading coefficient. Since it's in standard form, that's easy. Our leading coefficient, well, 4 is the highest power of x. The leading coefficient is negative. So we know that this thing finishes down. So when we're on the right side, we're going down. So that's negative infinity, right? And because our degree is 4, that makes it even. We know that it's the same on the other side because the even ones have the same end behavior. So we know that it's also going down on the left side because remember this means down, y going to negative. So I already know my graph is going to be down and down on the outsides, okay? Now the zeros in their multiplicity. So we have f of x equals negative x to the 4th plus 5x squared minus 4. I'm going to need to factor this to get the zeros. Whoops. So I'm going to plug in 0 for y. And factor out a negative. So then it will be x to the 4th minus 5x squared plus 4. And then I'm going to factor this again. So if it's x to the 4th, I know it's x squared and x squared. So now I'm just looking for numbers that multiply to 4 and add to negative 5. So that's going to be negative 4 and negative 1. And then I realize, oh, those are difference of squares. I could keep factoring. So I get 0 equals negative x and x. I'm just factoring this guy. I know that x squared makes x and x. 4 will make 2 and 2. Difference of 2 squares. Positive and negative. Then this guy will make 2 more factors. So we have x and x, because the x squared will be x times x, and the 1 will be 1 and 1. And then we know when we factor difference of squares, it's going to be 1 positive, 1 negative. So now I know my zeros are negative 2, 2, negative 1, and 1. So my zeros are negative 2, 0, 2, 0, negative 1, 0, and 1, 0. All right, so now I can check the multiplicity. Well, none of these are repeated, right? None of them are repeated. They're all powers of 1. So they all have a multiplicity of 1, which means they're just going to cross just like a line. There's no little turn. It's not like a cubic. It's just like a straight line that goes through. So, our y-intercept, we know we plug in 0 for for x and solve for y. So this is f of 0 equals negative 0 to the 4th plus 5 times 0 squared minus 4. That's going to equal 0 plus 0 minus 4. It's going to equal negative 4. All right, so let's start graphing this. We only need to go out to 2, so I'll make it a little wider. 1. We'll go like this. 1, 2, 3, 4. 1, 2, 3, 4. I don't have to label them. I'm just going by ones. 1, 2, 3, 4. 1, 2, 3, 4. All right. So we'll graph in red. Y-intercept at 0, negative 4. Just nice to have. Our zeros are at negative 2, 0, 2, 0, negative 1, 0, and 1, 0. All right, we know our end behavior is down on the left and down on the right. So we're going to be down and we're going to be down. So I know I start coming up here at this 0. I got to decide if I cross or if I bounce. They're all multiplicity at 1 and we cross. So at every 0, we're crossing and it's like a straight line. So I go through. So I'm going to come up here. I'm going to go through. I'm going to turn around, come here, and go straight through. I like to do this first before I sketch the whole thing out. I find out what's happening at the zeros. Okay? Then I'm going to come down here. I'm going to pass through my y-intercept, turn around. Maybe I turn around right at my y-intercept. Come back up. I'm going to cross that way. Straight line because it's a power of 1. I'm going to go up, and now I have to come back down to get to this 0. I'm going to cross. It's a multiplicity of 1. So it's going to be like a little straight line. And then I'm going to continue down. So it's going to go up, cross, go up somewhere, turn back around, come down. Hit this guy, turn around, go through, cross over. I don't know, maybe it goes really high and comes back. Maybe it just goes here and then comes back. So let's draw up, turn around, down, turn around, up, turn around, and down. And that's what that polynomial looks like.